Welcome to Tech Talks. Our platform edition today is focused on detecting and stopping bots using machine learning. Tech Talks is a series of short webinars focused on features and best practices within use cases. We value you, our customer, and want you to continue on your Splunk journey. Our experts help create these tips and tricks, and we want you to leverage them in your daily role. My name is Brian Hoover, and I'm a Splunk industry strategist for software and gaming companies. And today I'm going to share with you some information about bots and machine learning. But first, let me introduce my colleague, Anthony Tellez.
My name is Anthony Tellez. I'm a staff data scientist at Splunk, and I will provide a demonstration of the botnet app for Splunk, which leverages machine learning.
Thanks, Anthony. Let's get started. Today we have 4 major agenda items. First, we will describe what bots are and why we care. Second, we'll talk about detecting and stopping bots using Splunk machine learning. Third, Anthony will demonstrate the botnet app for Splunk. And fourth, we'll cover additional resources available to help you take advantage of machine learning to detect and stop bots using Splunk. Our team will be available for Q&A throughout over the Q&A feature. And if you are watching a recorded version of this webinar, please continue the conversation through the Splunk community website for any follow-up questions. So, what are bots? Well, bot is short for robot, and when we refer to bots, we're talking about software robots that are programmed to automatically perform a certain task without human intervention. They can imitate or replace humans, often doing so faster and with greater consistency. Bots can replace humans in all kinds of ways. For example, they can interact with pages and forms, click on links, scan text, and download content. They can post comments on social media, retweet, and even hold conversations with other humans, which you're probably familiar with. In that last case, we typically call them chatbots. There are estimates that over half the traffic on the internet is bot activity, as you might expect when you consider that search engines are constantly scanning and indexing web content. And of course, those search engines are bots. So what is the difference between a good bot and a bad bot? Well, typically, any bot that misuses an online product or service can be considered bad. So a web crawler like Google or Bing from a search engine is a good thing if it indexes your site and makes it easier for your customers to find you, as long as you indicate it's okay to index your site. A bad bot is one that tries to break into your users' accounts or cheat your users. For example, a bot that buys up all the tickets on an events website. Different industries have different experiences with bots, as you can see from the chart to the right. I think it's very interesting, for example, that the financial services industry sees as much as 50% of the traffic to their sites as bots, and the majority of those are bad bots. So what is the impact of all these bots? Well, both good bots and bad bots can impact the performance of your site negatively, slowing it down as the bots consume infrastructure or network bandwidth. Imagine, for example, you're one of those financial services firms, and it is costing millions and millions to provide services to bots that are also potentially negatively impacting your customer user experience. It becomes a big dollar discussion when you start considering how to eliminate 50% of the traffic that is bad bots, or roughly 25% of your entire service capacity. And to make it worse, bot activity is still increasing in volume and severity. Our goal then should be to quickly detect and stop the bad bots before they can hurt the business and steal assets and intellectual property. Splunk machine learning is invaluable in detecting anomalies and behaviors and data that human observers might miss. If you go to the Splunk website, you will see lots of examples of how ML is used for all kinds of use cases. So now we'll talk a little bit about how we use Splunk and machine learning to detect and stop bots. We call this bot management. It's the process that we use to block bad bots from undesirable activities while allowing good bots to access our websites. With bot management, we can profile bots based on their source and behavior so we know what we are dealing with and how to handle them. Complete bot management is a deep topic beyond the scope of this tech talk, but we can show you how to establish the foundation for your bot management practice using machine learning in Splunk. I'm now going to turn the presentation over to Anthony to walk you through how you can use machine learning to do bot management with Splunk.
Thank you, Brian. We will give a short demonstration of the botnet app for Splunk, which is available on Splunkbase for download. In this demonstration, we will go through the entire use case of how to detect a bot using machine learning.
The botnet app for Splunk is designed to showcase how you can leverage machine learning to train and build ML models to detect malicious traffic in NetFlow logs originating from bots. The app ships with sample data that is already labeled for you to make exploring much easier. The motivation behind this app is similar to the DGA analysis app, where we showcase supervised machine learning algorithms to classify network traffic based on behavioral features in the data and demonstrate a fully realized machine learning workflow in Splunk. These features can be derived using statistics or generated by a feature engineering algorithm. As we step through this demonstration of the app, we will make some choices around feature engineering and selection that will have an operational impact on the classification from the models. These trade-offs will vary depending on the amount of data used in the training and the type of algorithm used to generate the model. The background on machine learning section provides the user with some information about the ML terms used in the app and the meanings behind them. For people that are unfamiliar with words like classification and NLP, this dashboard will provide lots of contextual information. As we scroll down the panels, we start to learn more about the use case and some of the features we are going to leverage for determining if a particular network flow is associated with a bot. Provided in the last panel are links to further reading on each of the topics described in the app, and I would suggest leveraging these resources to get a better understanding in areas of machine learning where you need additional guidance or clarification. The Data Analysis and Feature Extraction Dashboard provides a comprehensive overview of the dataset and provides a breakdown of the total number of unique flows, type of flow detected, and the label associated with bot flows. This data is aggregated using SPL to provide better features that describe the flow behavior and the most frequently used protocol based on the common ports seen in the flow. The Feature Analysis Dashboard allows you to explore the different features in the dataset and how those features differ between normal traffic and botnet-generated traffic. You can also see the distribution of features for botnet traffic to better understand how the values of the features relate to each type of bot. This is valuable as you attempt to gather contextual information about which features are going to be good predictors of specific types of bot activity. As seen on the Data Analysis and Feature Engineering dashboard, the proportion of non-botnet records to botnet records is extremely high. This is likely to produce models that are biased towards predicting non-botnet NetFlow traffic. Therefore, the dataset needs to be generated containing an even split of botnet and non-botnet records. The approach we take in the app to create a balanced dataset is the application of undersampling. For undersampling, we will remove a random sample of non-botnet records in order to have a more even balance between the two different classes of records. Using this technique, we will remove the samples before we apply any pre-processing and before splitting into training and test datasets. The pre-processing dashboard allows you to select the scaling options, principal component analysis options, whether you wish to remove outliers, and the train test split ratio to be used in the subsequent dashboards. Selecting the checkbox will give you more information on the different pre-processing techniques. On the Anomaly Detection dashboard, you can train a set of anomaly detection models to baseline normal traffic for each botnet type. The idea here is to train models to understand the behavior of the botnet, whereas in production you would be more likely to train a model to understand the baseline for normal traffic. This anomaly detection model is useful in removing outliers from the data before passing these observations to the classification algorithm. The anomaly detection models can be inspected using the summary dashboard to understand the thresholds being used by the probability density algorithm for each of the numerical fields in our dataset. This is useful when you're trying to understand why normal statistical thresholds are failing to detect specific cases. For example, bots that have Gaussian KDE distributions or exponential distributions would generate many false anomalies if a normal bell curve-like distribution was used. The Model Threshold Dashboard allows you to test the thresholds applied to the data in order for you to determine how sensitive you want the anomaly detection model to be to outliers. Smaller values will exclude local outliers, while larger values will include global and local outliers. The Model Training Dashboard is a classification step where we begin to build models that are predictive of a class of bot. Data is passed to the algorithm after being filtered by our anomaly detection thresholds. The testing dashboard leverages the models that are built to validate how well it is performing against data it was not trained on. This provides us with a picture of precision, recall, accuracy, and F1 scores for each classification algorithm in the machine learning toolkit. It gives us a holistic picture of which algorithm will perform the best given the data in the current state. The recommended algorithm can change depending on variations in your selection and the features and outlier thresholds. The Next Step dashboard is a dynamic panel that can produce SPL to leverage the models built through the process. This can be used against real data stored in your Splunk instance. Simply select the index where your NetFlow data is stored and determine which algorithm you'd like to use. I suggest using the one that was recommended on the previous panel. Simply paste this SPL into your Splunk search bar to begin detecting potential bots.
Thank you for that demonstration, Anthony. On this slide, you see some additional resources for you to continue your journey. There's 4 here, and we hope that you'll follow up on these and start establishing your own botnet management resources. You'll also receive these links in a follow-up email. So if you can't get those links down now, don't worry, you'll get them in the email. As I mentioned earlier, whether you are joining us live today or watching this at a later date, please continue the conversation with us on our Splunk community website. We have a wealth of users who are happy to answer questions you may have in Splunk Answers. You can view the new discussion sections for additional platform tech talks, and the community site also includes Splunk Ideas, where you can submit new product enhancements. We really appreciate you taking the time out of your schedules to join us today. Please tune back in for future Tech Talks. We are excited to share the series with you.